While the Mesozoic era was filled with large, carnivorous dinosaurs, very few of these predators were close to the size of Tyrannosaurus rex. Even fewer were as large, or potentially larger. Well-known examples are Spinosaurus, Giganotosaurus, Carcharodontosaurus, and Mapusaurus. However, there is one other theropod that, while much more obscure than even Mapusaurus, also potentially rivaled the Tyrant King in size. Its name is Tyrannotitan. Tyrannotitan was first found in 2005 in Argentina. Besides numerous isolated teeth, it is only known from 2 incomplete specimens. From these, it is estimated to have been between 11 to 13 meters long, with a weight between 5 to 7 metric tons. Tyrannotitan lived during the Early Cretaceous, specifically during the Albian stage, which lasted from 113 to 100 million years ago. Despite the name, Tyrannotitan was not a close relative of Tyrannosaurus. Instead, it was a Carcharodontosaurid, the same clade that also includes the fellow megapredators Carcharodontosaurus, Acrocanthosaurus, Giganotosaurus, and Mapusaurus, as well as smaller species including Siamraptor and Concavenator. Tyrannotitan was most closely related to the fellow South American Carcharodontosaurids Giganotosaurus and Mapusaurus, forming the smaller clade Giganotosaurini. All 3 were found in Argentina at slightly different times. Given the massive territory required by such massive predators, it is doubtful that a continent could support more than one of these species at a time. Therefore, it is possible that Giganotosaurines may represent a single lineage changing over millions of years. As Tyrannotitan was both the most basal and oldest Giganotosaurini, it may very well be the direct ancestor of its later, more famous relatives. In most regards, Tyrannotitan was similar to the other large Carcharodontosaurids, though it had its own unique traits as well. The most striking feature of the Carcharodontosaurids were their deep skulls, which were massive even in proportion to their bodies. Their skulls were thinner and less robust than Tyrannosaurus's, resulting in a weaker bite force. This was remedied by their teeth. Like their skulls, they looked broad from the side, but thin when viewed from the front. They were lined with serrations that made them excellent at slicing through flesh. In comparison to the other Mega-Carcharodontosaurids, Tyrannotitan's teeth were thicker and straighter. The vertebrae in the hips and tail of most other Giganotosaurines were pneumatic, or hollow, which reduced their overall weight. Tyrannotitan lacked this trait, which would have made its tail heavier compared to its relatives. The neural spines of its tail vertebrae were also much taller than normal, perhaps to support the larger muscles needed to support the heavier tail. The neural spines along the back were also taller than in Giganotosaurus, giving its back a slightly more curved appearance. The arms of the other large Carcharodontosaurids were smaller than most other theropods. Like in the Tyrannosaurids, this would have allowed their heads to become larger without becoming too top-heavy. Unlike the Tyrannosaurids, they were still large enough to imply they still served an important role when hunting. In contrast, and perhaps appropriately for a species that also has tyrant in the name, Tyrannotitan's arms were smaller than its relatives. Paradoxically, Tyrannotitan's arm muscles seem to have been more powerful, not less. Either way, Tyrannotitan's teeth were still its primary weapons. While small sauropods and juveniles of larger species would not have been a problem for most large theropods, Tyrannotitan lived alongside Patagotitan. With an estimated weight of 55 metric tons, it is one of the largest known sauropods. Patagotitan has even been suggested to have been larger than Argentinosaurus, usually considered to be the largest sauropod, though this is still under debate due to the lack of complete skeletons of either species. Regardless, an adult Patagotitan would have been too great a challenge for most carnivores. However, Carcharodontosaurids like Tyrannotitan seem to have specialized in such gigantic prey. Rather than kill them in one quick attack, they are thought to have used their razor-sharp, flesh-cutting teeth to wound the sauropod over and over again until it finally died from blood loss or infection. Tyrannotitan may not have even waited for its prey to die before eating. By slicing off parts of its flesh during these attacks, Tyrannotitan could feed without necessarily killing its prey. This strategy, called flesh grazing, would have been particularly useful since it may have taken a long time for a Tyrannotitan to actually kill an adult Patagotitan. It is also possible Tyrannotitan was a pack hunter. Fossils of at least 7 individuals of the Giganotosaurine Mapusaurus have been found in a single bone bed, which some paleontologists have interpreted as a pack. While it would normally be difficult for an entire pack of such large predators to sustain themselves, especially when they are contenders for the title of largest terrestrial carnivore, sauropods the size of Paleoenvironment or Argentinosaurus would have provided more than enough meat to satisfy such a group. As Tyrannotitan was closely related to Mapusaurus, it may have lived in groups as well. Another possibility is that rather than hunt in packs, Tyrannotitan usually lived alone but came together to form temporary mobs to take down massive sauropods like Paleotitan. This would provided a best of both worlds scenario, allowing Tyrannotitan to hunt smaller prey without overtaxing the ecosystem while also providing it access to the rarer giants. Or it could simply be that Tyrannotitan did not hunt adult Paleotitan, instead preying upon larger juveniles, albeit far larger juveniles than almost any other theropod could ever hope to bring down. When Tyrannotitan was alive, Argentina was a humid floodplain. Besides Paleotitan, not much is known about the fauna contemporaneous with Tyrannotitan. The few other species known from Argentina during the Albian stage include smaller sauropods, the primitive Ceratosaur Giganotosauris, and terrestrial crocodilian relatives called Periosaurids. Finally, there are the questions of whether Tyrannotitan was larger than Tyrannosaurus, and whether it was the largest theropod. Unfortunately, since Tyrannotitan is only known from incomplete remains, it is difficult to estimate its exact size. The same goes for the other Mega-Carcharodontosaurids and Spinosaurus, though available fossils suggest Giganotosaurus has the best chance of being the largest Carcharodontosaurid. Out of the largest theropods, only Tyrannosaurus is known for complete enough remains to give a reliable size estimate. As mentioned before, Tyrannotitan is estimated to have been between 11 to 13 meters long. The upper estimate is comparable to the upper length of the largest two Tyrannosaurus specimens, Sue and Scotty. On the other hand, Tyrannotitan's weight is thought to have been between 5 to 7 metric tons, while Scotty is estimated to have weighed 8.8 tons. However, Scotty and Sue were exceptional. Most adult Tyrannosaurus are only thought to have weighed between 5.4 to 8 metric tons. As Tyrannotitan is only known from 2 specimens, it is currently impossible to know how representative they were of the species as a whole. Assuming the 2 known Tyrannotitan specimens were close to the standard, it seems the average Tyrannotitan was longer than Tyrannosaurus but weighed less. Regardless of which species had the larger average size, it does seem there was overlap between the two, as well as the other megapredators. Whether or not it was a record breaker, Tyrannotitan was certainly one of the most massive terrestrial predators that ever lived, and was the most dangerous predator in South America during the Albian stage of the Cretaceous. Thank you for watching. I hope you learned something interesting. Have a great day, and if you enjoyed the video, please remember to hit the like button.